This little robot is capable of finding the sun and pointing a solar panel directly at it. Solar panels produce maximum power when oriented toward the sun. This device is an active solar tracker, following the sun from sunrise to sunset. If you have some basic knowledge of electronics and computer programming, you can construct a robot like this. This sophisticated device is the brain for our robot. It's a microcontroller, a miniature computer. With a few lines of code and the proper connections, it drives this robot. This controller costs about $20 and is available from a company named Pololu. The company calls this controller the Micro Maestro. It is designed to drive 6 servo motors. This board is the Mini Maestro. It is designed to drive up to 12 servo motors. I use this one in the project. Servo motors, or servos, are the same motors used in radio-controlled models. They are robust and inexpensive and fully controllable. Typically, they have a rotation range of up to 180 degrees. Servo motors plug directly into the board connectors. To create 2 axes of rotation, I connected 2 servos together. One servo rotates the other one. I mounted the solar panel on the upper servo. It is responsible for vertical rotation. The lower servo takes care of horizontal rotation. The board is connected to a computer with a USB cable, and I'm using the Maestro Control Center. This is software included with the controller to test servo motion. The next step involves installing and configuring some light sensors. We need these to detect the sun. To do this, I use the software to select 2 servo connections and change them to inputs, capable of receiving a signal. The signal must be a varying voltage, and it is important that the voltage falls within the ranges specified for the controller. Next, we need to create light sensors. The simplest way to do this is to use 2 photoresistors configured as a voltage divider. Photoresistors are devices that change resistance with light level. 2 photoresistors connected together create a voltage divider. Make sure the current flowing through this configuration falls within the current tolerances of the board. I mounted the resistors in a mini tower, with the 2 horizontal sensors at the bottom and the vertical sensors in the top. The tower sits beside the robot facing south. Light falling on the sensors changes their resistance and creates a varying voltage at the input pins. Using this voltage, the microcontroller generates a number for both the horizontal axes and the vertical axes. These 8-bit numbers vary from 0 to 255 and provide information about the location of the sun or other light sources. It is possible to use these numbers to control the servos. A simple scripting language can be used to accomplish this. This scripting window is one of the tabs on the Maestro Control Center. This code collects information from the sensors and directs the servo motors to move the solar panel towards the sun. The sensors are now responding to light levels, delivering a varying voltage to the input pins. The code interprets these signals to drive the servos and orient the solar panel for maximum exposure to the sun. This configuration, with the sensors separated from the robot, simplifies the coding. To work properly, both the robot and sensors must be oriented facing south. I have just given the basics of this controller and its capabilities. If you visit the Maestro website, you'll find detailed information about using this product and other robotic projects. For more science projects and videos, visit our website, hylaroad.com. Follow the projects link.